Hello, I'm Michael Collier. On this field trip, we're exploring the volcanoes and glaciers of Iceland, a place where fire and ice are on better display than anywhere else in the world. There are good examples back in the United States, so why come all the way to an island in the middle of the North Atlantic? Well, precisely because Iceland is in the middle of the Atlantic. It's where the Mid-Atlantic Ridge rises from the ocean and becomes visible on land. The Mid-Atlantic Ridge is a 10,000-mile-long underwater range separating the continents of Eurasia and Africa from North and South America. Magma wells up in the center of the ridge, spreading the seafloor apart and creating new plates of oceanic crust. Along almost all of its length, the ridge is a mile or more below the surface, but in Iceland the ridge rises above the waves. We'll be on the road in a country steeped in Norse tradition, tethered to the sea, incomfortably rural. It turns out that the militaristic Norse knew a thing or two about geology. They named this Skalbjörn, or Shield Mountain, and today it remains one of the world's best examples of a shield volcano built up by repeated thin basalt flows. The Norse named this Glacier, and today the word is applied to geysers around the world. We'll do things a little differently on this field trip. We'll tag along with Dr. Dan Kelly, who teaches geology at Bowling Green State University in Ohio. He's convinced that geology is most compelling when it springs firsthand from encounters with rocks and landscapes. He's done research on Iceland's volcanoes, and he takes students there whenever possible. Dan wants them to observe and ask questions, to use rock hammers and a hand lens to find answers. Jenna is one of those students on this trip. She's graduating soon. 7 other students are also along, each with differing levels of geologic experience. Let's join them on a tour of the volcanoes and glaciers of Iceland. Here, plate tectonics is more than just some lines on a map. In southwest Iceland, the Mid-Atlantic Ridge is a very real zone of extension, 20 to 30 miles wide. Magma wells up from the underlying asthenosphere and spills out onto the Reykjanes Peninsula. Near the waterfall at Gullfoss, that magma froze into columnar joints with their characteristic hexagonal shape. On the peninsula, tensional fractures run roughly parallel to one another, all trending northeast-southwest. Cinder cones and small craters dot the landscape, all aligned northeast-southwest. These linear patterns are clues that we really are walking on the Mid-Atlantic Ridge. A rifted section of the ridge is clearly visible at Thingvellir, just north of Reykjavik, where Icelanders convened their first parliament just over 1,000 years ago. Iceland straddles a plate junction dominated by compression, extension, strike-slip movement. Iceland lies on top of the Mid-Atlantic Ridge and is dominated by extension. Out on the tip of the Reykjanes Peninsula, Jenna follows Dan to the base of a wave-cut cliff that's been lifted out of the sea. The rock is black, a basalt with gas bubbles called vesicles frozen in place. Erosion of the cliff reveals hundreds of ellipses, 2 feet high, maybe 3 feet across, flat across the bottom. The rims are fine-grained, even glassy in appearance. These are pillow basalts, formed when a basaltic magma erupted underwater. Suddenly, plate tectonics seems awfully close at hand. Iceland's southern coast, east of the Reykjanes Peninsula, is marked first by farms, and then by high green cliffs. A ferry crosses to the Vestmann Islands, where a 1973 eruption added almost a square mile of new land. There's a trail on the island that leads through a prickly basalt flow and up a cinder cone called Eldfell, or Mountain of Fire, a great vantage point for sketching maps, even if it is raining. This basalt flow swallowed 400 homes in the town of Vestmannaeyjar. During the eruption, sulfur-rich fluids and gases coated some of the cinders, turning them yellow. Waterfalls crowd the coast around Skogar, where Dan and his crew return to the main island and continue east. This is where Eyjafjallajökull erupted in 2010, or as they say in Iceland,
Eyjafjallajökull.
Ash from that eruption snarled air traffic across Europe for a week. But Icelanders are accustomed to volcanoes popping off. Farmers not 5 miles away just kept plowing as the eruption proceeded. Vestmannaeyjar, Eyjafjallajökull, and the central part of Iceland behave differently than the flatter Reykjanes Peninsula where rifting is so obvious. The crust is still spreading, but volcanoes in the central portion of Iceland are also creating new islands and building 6,000-foot high mountains. Dan explains that the crust of Iceland is thicker than the rest of the mid-Atlantic ridge because of a plume of hot rock rising up from the mantle. The plume is adding its own magma to magma generated by a typical mid-ocean ridge. That combination of plume and ridge is why Iceland is an island and not just another underwater segment of a rifting ridge. With so many volcanoes, why then is this island called Iceland? What do you get when a lot of snow falls on tall mountains at high latitudes? Glaciers, of course, and aptly named Iceland is no exception. Vatnajökull, Iceland's largest glacier, covers more than 3,000 square miles, about 8% of the island. This ice cap is 1,300 feet thick, more in places, spilling out onto the surrounding lower elevations in 30 outlet glaciers. As with most glaciers, water from rain and melting percolates down through the ice, flowing as subglacial streams. But what happens when a volcano erupts under a glacier? Lava that's 1,300 degrees Celsius can melt a lot of ice. This water and lava mixture often leads to violent eruptions, sending ash and cinders high into the atmosphere. That's why Eyjafjallajökull crippled the airlines in 2010. Alternatively, the water might pool up beneath the glacier, trapped until it suddenly breaks out as a massive flood called a jökulhlaup. When Grímsvötn erupted in 1996, it set off a jökulhlaup well in excess of 1 million cubic feet a second. In 1755, nearby Katla volcano set off a flood that was 4, maybe 8 times as large. That's like waking up and finding a couple of Amazon rivers flowing through your backyard. Dan and his students tiptoed across barren floodplains beneath Vatnajökull that are periodically, unexpectedly underwater. Let's be honest. Glaciers are interesting, but volcanoes are Dan's first love. We push on around Iceland's east shore. Basalt on this and the corresponding west side of the island is older, a little more than 3 million years, and has had longer to pull away from the mid-Atlantic ridge. Younger dikes everywhere slice up through older basalt. We continue our circumnavigation, heading north, eventually only inches away from the Arctic Circle. More volcanoes. Verfeld is a tephra crater that formed when an explosion 2,500 years ago threw fragments of ash and cinders into the air, landing as a broad circular ring. Krafla erupted as recently as 1984, pushing up rubble within its crater, leaving behind lava tubes, and providing heat to power a nearby geothermal generating station. Ischia Volcano violently erupted a century earlier, creating an inner caldera which is now filled by Askjavatn Lake. Dan Kelly and his students came a long way to see the volcanoes and glaciers of Iceland. Was it worth it? The short answer is yes. Nowhere else could they have walked along such perfect exposures of the mid-Atlantic ridge. Yes is also the long answer. This trip provided the opportunity to examine an important aspect of plate tectonics, beyond the classroom and out in the real world. Will this Iceland experience lead Jenna and her peers to be better students of geology? Well, Jenna's applying to graduate school. Tune in a few years and see where her career leads. And even if the others choose to study something else, the world will always be bigger for their having seen this landscape through the eyes of a geologist. What did you learn? Iceland behaves differently than other segments of the mid-Atlantic ridge because there is a nearby subduction zone. It's also underlain by a mantle plume. Its magma tends to freeze into rhyolite rather than basalt. Iceland behaves differently than other segments of the ridge because there is also a contribution of magma from a mantle plume. If given the chance to study geology in Iceland, you would go, stay home, consult a lawyer. I would go in a heartbeat.